Hello guys, welcome to a new video. And before I start this video, if you haven't done so, go ahead and follow me on Twitter at CCNA Daily Tips. I post a lot of tips, a lot more content here from my website, which is ccdtt.com. And I also post a lot more labs, as you can see here. And other times I also post some quizzes and test questions for the CCNA and also for the CCNT. And if you have been watching my videos, if you haven't subscribed to my channel, go ahead and subscribe to my channel. I have plenty of videos right here. As you can see, if you go to my channel, I have over 70 videos right now as of today. Maybe by the time you're watching this, I will have over 400 videos because I make at least one video every day. Okay, so at least expect one video from me to come to my channel every day about different topics. Alright, so let's go ahead and start. And what we're going to do is we're going to talk about the spanning tree protocol a little bit, and what is the spanning tree protocol? So it's a network protocol that builds a loop-free logical topology for Ether networks. So if we have a loop in our network, what spanning tree does, it gets rid of that loop, so we don't have a what is called, I believe it's called, not a domain storm, but it is called it is called a storm, not a bridge storm. I can't think of the name right now, but it's just to have a loop-free topology in our network. Okay, so when STP is enabled by default on all the Cisco switches, and the way it does this is by first, when you plug in a port, what it does is it goes into the blocking state, and then it goes into the listening state. This is the listening state is when the switch processes PPDUs and waits for possible new information, and then after a couple seconds it waits and goes to the learning state, and this state is just while the port does not yet forward frames, it does learn the source address from frames. Okay, and the last one, that's when I'm gonna show you right now when I plug it in. When this goes green over here, that's when it's forwarding, so that's like the last state. And a port receiving and sending data in Ether frames, normal operation. The forwarding port monitors incoming BPDUs that will indicate it should return to the blocking state to prevent a loop. Okay, so that's what it does, and I'm going to show you. There it is. When it is green right here, that means that it is in the forwarding state. Okay, and also while this is happening, they are trying to figure out which one is going to be the root bridge, right? And the root bridge is actually it's going to be a switch with the lowest priority number and also the lowest MAC address. So it's going to combine the priority number plus the MAC address of the switch. Okay, and since all the switches by default have the same priority, what's going to end up winning is going to be the MAC address. So the switch with the lowest MAC address is going to become the root bridge, and the root bridge is going to actually be it's kind of like the manager of that root. Okay, so if this one becomes the lowest, if it is the lowest priority number and the lowest MAC address, this one is going to become the root bridge. Okay, so like let's say this is going to be the root bridge for VLAN 1. So this one is going to decide which port we are going to block and which port we need to put it in forwarding state and all that stuff. Okay, and also the way the other switches do, because when you have on a switch right here, let's see that let's say that switch 1 is a root bridge. So this one over here, switch 2, has to come out with the root ports and the designated ports. And the root ports is actually the shortest path to the root bridge. Okay, so since this one is the only one, this link over here is going to be a root bridge to the root port. The root port to the root bridge, which is this one right here. And the it does this by the link speed and cost value. So if we're gonna have about 100 megabit per second link, so the cost for that is going to be 19. But if we have another link right here and another link right here, the cost is going to be 38 instead of just being 19. So this one is the shortest path. So this one is going to become the root port. And since this one is a root port, this one over here is going to become the designated ports. So let's cancel that. So this is enough about talking about STP. Let's go ahead and start configuring our own spanning tree. And what we're going to do is just take a look at spanning tree and see which one is going to be the root bridge, right? So switch down right here, and remember guys that by default, 03, this one is going to be 03 as well, and by default we are going to be running PVST. And PVST stands for per VLAN spanning tree protocol, and what that does is that a spanning tree is going to be defined per VLAN, but since we're only running one VLAN, which is VLAN 1, the only VLAN that they're going to argue about is going to be just VLAN 1. Okay, so right now, as you can see, I can tell you right now which one is a root bridge already. So since these two interfaces right here are actually green or enable, right? They're not blocking like this one right here. I can tell you that switch 1 is the root bridge for VLAN 1. And the way we can find out is by going over here. Let's go and it show spanning tree, and you can see right here that if we come over here, I did the show spanning tree, and this one is for VLAN 1, as you can see right here, because we're only running VLAN 1. So if we come over here, the root ID, the priority of the root ID is 32769. Okay, which one is the default with all the switches. And the MAC address of the root bridge is this one. Okay, and the bridge ID, which is the ID of this local switch 2, it has a priority of 3269, which is the same as the root bridge, but since the MAC address of the root bridge is lower than switch 2, this one wins, and this one is actually became what is known as the root bridge over here. And you can see right here that fast Ethernet 01, which is this one right here, 01 became the role that it took. It became the root bridge right here, and the root port, and the root port is the one with the lowest cost to the root bridge, which is this one right here. So since this one is the closest to the root bridge, this one became the rule, and it is foreign, and the cost for it is only 19, which is only one link, and is going over at 100 megabits per second, which the cost is 19, so you can see right here, right? And the fast Ethernet 02, which is this one over here, right? We can tell that it is in the designated state, okay, and it is foreign right now, and the cost for that is 19. Okay, but what happens is if this one goes down, what's going to happen, this one is going to become active, and it's actually going to become the root bridge, I believe. So let's go ahead and do that and see what happens. Config T into fast Ethernet 01. Let's just shut it down, and let's go show spanning tree. let's see. What's happening right now is that spanning tree is running right now. And what it's doing is it's trying to find out another way to get to this root bridge over here, since this one went down, right? So if we fast forward, now you can see that it went green, and this port right now should become the root bridge. There we go, the root bridge and forward status, right? And the cost for it is 19. But let's go ahead and go back, config T interface, config T interface fast Ethernet 01, and no shutdown. Right, and when we do a no shutdown again, what's going to happen is from the blocking state is going to go to the listening state, then the learning state, and then the forwarding state, and that should take about 30 to 50 seconds, but I'm just going to fast forward, and there we go. Now if we go and end that again and do a show spanning tree, we're going to see now the fast Ethernet 01 came back up, and it became the root port because it's the closest one to the root bridge, and this one became designated right here, but it is forward. The one blocking is on switch 3, and we can also take a look at switch 3. Enable, show spanning tree, and here we go. So the role for fast Ethernet 02 is alternated, so it is alternating, and you can see right here that fast Ethernet 02 is in the blockage state, and that means that we are preventing a loop by blocking this one and not and disabling this port, because if this port is enabled, what's going to happen is we are going to get packets everywhere on a loop, and it's going to destroy our network, right? And so you can see that fast Ethernet 03, which is this one over here, which is the closest one to the root bridge over here, became the root port, and it is forwarding state, and the cost for it is 19. So what happens if we shut down this fast Ethernet 3? Let's go ahead and take a look at that. The fast Ethernet 3, let's do a shutdown, do show spanning tree from here. As you can see now, this one actually became the root. All right, so if we fast forward, so it can go up, let's do it again, and you can see now there is a root, and it became a forwarding state, because now since this one is not working anymore, the spanning tree found out that it was not working anymore, and this one became active. So now let's go ahead and do a no shutdown. So spanning tree sends a PPTU frame every 2 seconds. So every 2 seconds it's sending packets on that same link, making sure that the link is still up. Okay, and that's why it happens so fast. And you can see right now the link came back up, and this one became the blocking state, and the other one and 03 became the root port, which is the closest one to the root bridge. And now let's take a look at the root bridge, and let's see what we can see right here. Enable, config T, not config TN, show spanning tree. Alright, and from the spanning tree, what you can notice is first that for VLAN 1 spanning tree protocol is IEEE, which is per VLAN spanning tree. The root bridge, the priority is 32769, and just take a look at this. The MAC address is 0650C1EB, and the bridge ID, which is a local, is the same MAC address. And you know what that means? Well, what that means is that this bridge is the root. So this is the root. This is the root bridge. Okay. So since this is a root bridge, where you can see is the ports are designated, and they are both on the forward state, because when you are the root bridge, you have to have all your ports that are connected to you need to be forward, right? Because all these switches are connected, directly connected to you, and you have to reply to them. Okay, and one way that you can manipulate which one becomes the root bridge is by configuring the priority. Okay, so if you have a lower priority than this, then the switch becomes the root bridge. And let's see that you configure this topology, blah blah blah, but actually switch, let's just say that switch 3 has a higher MAC address than switch 1, but switch 3 is the most powerful switch that you have on your network. Then you want switch 3 to take care of the to be the root bridge, because it has more power and it can get all the data without slowing down, and it runs faster than switch 1. Then what you could do is configure switch 3 to be your root bridge, and the way that you can do that is by going to the configuration mode and do a spanning tree from here, and then VLAN 1, which is the only VLAN that we have configured. So VLAN 1, you want it to be the priority. What you could do is lower the priority and do priority of 0 right here, right? And what's going to happen, as you can see right here, it's already switched. So switch 2, as you can see, it used to have fast Ethernet 1 as a root and 02 as a designated. What happened now that switch 2 on fast Ethernet 2 is going to have the root right here, the root port, and on fast Ethernet 2 is going to be designated, and the state is going to be blocking, as you can see right here. And here we go, it's alternating and it's blocking, and this one is a root and it is in the forward state, right? And you can see right here, so the root bridge and the priority is equals to 1 to the root bridge, right? And the root bridge is switch 3. Okay guys, and the bridge ID, which is the local one, the priority is still 32769. So since this one is higher than switch 3, then switch 3 is now this is the root bridge. Okay, so this one became the root bridge, and as you can see right here, the root bridge ID, the priority is 1, which we configure to 0, so 1, and the MAC address is 0 D0FFAD A576, which is the same to the local. So that means that this is the root. Okay, as you can see right here. So this is how you can manipulate this one. So if you want to manipulate your network and actually have another switch to be the root bridge, you can do that by setting up by lowering the priority. Okay, so let's go ahead and put the priority back to what it was before, and I believe it was, let me see, priority 32769. Okay, and if we put the priority back, what's going to happen? All of the switches are going to have the same priority, but since switch 1 has the lowest MAC address, it's going to go back to switch 1. Let me see, did I do it right? Spanning tree, priority, mouse increment. Oh, not 6.9. I'm sorry, it's 6.8 because it adds 1 because the VLAN. Okay, so here we go. So it's 32768, and it just adds a number because it adds the VLAN number, which is number 1. Okay, so we will switch it back to here. You can see now that this one became in the blocking state again. So if you go back to switch 1, this one is the root bridge again, and this one is not the root bridge anymore. Here we go. So this one is the fastest dancer 3 is a root bridge, which is going to switch 1, and this one became the root bridge again. Remember before we would make switch 3 the root bridge, this is what we had, and now since switch 1 is a root bridge, this is what we got now. Okay, and like I told you guys that what we have, the switch by default is running per VLAN spanning tree, and that means that per each VLAN we can set up a root bridge. So we can set up, if we have VLAN 1, we can set up switch 1 to be the root bridge for switch 1, and this one VLAN 2 we can set up switch 2 to be the root bridge for VLAN 2, and this one to VLAN 3, and just do it like that. Okay, and the way we can do that, I have a couple videos on my YouTube channel, and if you want to learn to do that, you can go ahead and go to my YouTube channel and just search for anything that contains either rapid per VLAN spanning tree protocol or just spanning tree protocol, and I have plenty of videos on how to do that. Okay, so just go to my channel, subscribe to my channel, and also if you enjoy this video, go ahead and follow me on Twitter at CCNA Daily Tips. Also, you can go to my website for some more packet tracer activities like this and more at ccdtt.com. And thank you guys for watching. I hope you guys enjoyed, and I see you on the next one. Bye bye guys, love y'all.